In this video, we'll be using the second derivative test to find relative extrema. The theorem that we'll be using is let f be a function such that the first derivative at c is equal to 0 and the second derivative of f exists. If f double prime at c is positive, then f of c is a relative min. If the second derivative at c is negative, then f of c is a relative max. And if the second derivative at c is equal to 0, the test fails and we have to use the first derivative to determine relative extrema. The problem that we'll be doing is to find all relative extrema of the function f of x equals x squared plus 3 sine x over the closed interval from 0 to 2 pi. And then we're asked to discuss points of inflection and concavity. So the first thing we want to do is find our critical numbers. We'll find the first derivative of f, and that is 2x plus 3 cosine x. Now to find our critical numbers, we need to set this equal to 0. And we'll need to use our graphing calculator to find the places where this function is equal to 0. I'm going to graph it and zoom trig. It looks like it crosses the axis here at this point, but our interval is from 0 to 2 pi. So I don't think we're going to have any places where it crosses, but let me change my window so that my x min is 0 and my x max is 2 pi. And then we'll use a scale of pi over 2. Alright, so we can see that from 0 to 2 pi we have no zeros, which means that we have no critical numbers, therefore no extrema. Now we're also asked to discuss points of inflection and concavity, which means we need to find our second derivative. Let's do that now. Our second derivative will be 2 minus 3 sine x. Now if we set this equal to 0, we have 3 sine x is equal to 2 sine x is equal to 2/3. Now we need to find the x values where this is true, and so I need to arc sine both sides. To get my values for x. So arc sine 2 divided by 3 is 0.7297. Now we also know that sine is positive in the second quadrant. So if my reference angle is 0.7297, I can find this angle in the second quadrant by taking pi and subtracting that angle pi, subtract, and then I'm just going to do my answer, my previous answer. And it looks like we have 2.4119. So now, using this x value and this x value, let's check the concavity, 0.7297 and 2.4119 on the interval from 0 to 2 pi. We use a test value in this interval of 0.5 and a test value in this interval of 1 and a test value in this interval of 3. So I need to enter my second derivative and get my signs in each of those intervals. I have 2 minus 3 sine x, and I'll want to put 0.5 in, so 0.5 store x, and that looks like I get 0.5617. So this is positive in this interval. Now if we store 1, we get a second derivative that's negative, negative 0.5244. And then if we store 3, we get a positive 1.5766. Okay, so when the second derivative is positive, in this interval we have concave up. In this interval, the second derivative is negative, oops, so it's concave down. And in this interval, my second derivative is positive, so it's concave up. So whenever our second derivative, our concavity, changes from concave up to concave down, then we have a point of inflection. So we have point of inflection at 0.7297. I'll find my y value here in just a little bit. And then we also were going concave down to concave up, so we have a point of inflection here as well. And I'll find my y value. So to get the y value, I need to put this x value into my original function, which was x squared plus 3 sine x. So x squared plus 3 sine x, and I'll ignore the value here that comes up. And I need to get this back. The way I got that number was to arc sine 2/3. Let me store that for x. If I second enter, I'll get the value for this function. There it is. So press enter, And it looks like my y value when x is 0.7297 is 2.5325. Right. To get this x value, remember I took pi and subtracted 0.7297. So pi subtract x. There's my 2.411. Now let me store that for x. And then find out what my function is. So 7.8171. So this is my points of inflection. And we're also asked to discuss the concavity. I kind of did that here, but I'll go ahead and list that concave up from 0 to 0.7297. And also from 2.4119 to 2 pi. And then concave down on this middle interval. So 0.7297 to 2.4119.